notice about f of x is equal to 1 over x? It comes up with two curves. That's the biggest thing. There are two curves. Actually, no. I doubt it. No money either. Alright, so there are two curves that come up from this. And what these curves are called, and I'm going to use this, and I can't guarantee that it's actually going to come out really good, because my microphone doesn't extend out to the screen too well. Each one of these right here is called a branch. So that's a branch, that's a branch. So just kind of deal with the fact that I'm trying to write with a mouse and it doesn't really work that well. So there are two branches to this. And there are a couple things that I need to ask you. Primarily, what can you tell about these branches? Where do they go and where they... This is what you want to this is what you want to get out of this, is where do they go? Wow. Let me see what I can do over here. All right, let's see. All right, calm down. All right, so for these branches, we need to ask ourselves two questions. Where do they go? That's one of the big questions that we need to ask. And then the other question is, where do they don't go? Okay? So those two questions, if we can answer those two questions, we're in business. Now, if we look at the branches, there are two branches, correct? There's one in the first quadrant. We get a nice branch in the first quadrant. Get a nice branch in the second quadrant. If we took a look at our table of values, if we said, all right, well, if we're dealing with the table of values, then let me hit Control T, and when x is 0, what's my y value? Undefined. So when x is 0, the y value is undefined. So is there any answers on the y-axis? So if there are no answers on the y-axis, that's a place where we can't go. So when we talk about where don't they go, when x equals 0, f of x is equal to 1 over 0, which is undefined. And a rational function, I'll pull that up here. Rational functions are kind of defined by not only where the branch is, but what are the parts that aren't defined as well. Now, I need to get rid of the of f of x at x equals 0. Now, when we deal with functions, we ask ourselves, all right, we're going to plug in an x into this, and we're going to get an answer of some kind. Well, we found out that when x equals 0, we got an answer. We got an answer of undefined, which means there's no value of f of x. 1 over 0 doesn't work. Now let me ask you this. Where else does 1 over x, if we're dealing with f of x is equal to 1 over x, where's another problem? Where's a problem with 1 over x that we have to deal with? Let me ask you this. 1 over x cannot equal 1 over x cannot equal a certain number. What was that? No, not 1 over 0. My question to you is this. Try to figure out what value doesn't exist. I have all these values here and up to here because the graph represents the values that you can have. So I can have all these positive numbers and it keeps going and going and going and getting closer to a number. This one has all these positive numbers or negative numbers and it gets closer and closer and closer and closer. Now here, does it ever hit the y-axis? No. Because in this case the y-axis is off limits. And you can kind of tell that, and you can, what I want you to do is I want you to start thinking of graphs that when they appear to be going closer and closer and closer to a number, chances are that they're never going to actually hit that number. And a lot of graphs that you deal with, a lot of the non-polynomial functions do that. They run up really close to a number, but they never actually get there. So they're never actually getting to the y-axis here. And we know that because it's undefined at the y-axis. But we can be really, really, really close to it. We're just never going to hit it. Now, what number on the y-axis do we get really, really, really close to in two different directions, but we never actually hit? Well, do I hit a 1? Is there a red point at 1? Yeah, right there. What about 2? 3? Yeah, 1 hits it here, 2 hits it here, 3 hits it there, 4 hits it there. If I go for a half, I'm there. -1 right there, -2 right there, -3 right there, -4 right there. What's the number that I don't hit? 0. That's 0. Just think, if I have to do this, and if I say, well, I want this to be equal to 0, 0 is equal to 1 over x. If I want it to be 0, 0 is equal to 1 over x. How do I solve for x? Multiply both sides by x. Those x's divide out. I'm left with 1 is equal to 0. Is 1 equal to 0? No, that's false. Therefore, f of x can't equal 0. And that's what we get here. There's actually a line here at f of x equals 0. So f of x is never going to hit where f of x is equal to 0. Just like those are your two big things. F of x doesn't exist where x equals 0, and f of x equals 0 doesn't exist. Because, as we kind of did up there, and I know it's kind of jumbled a little bit, we found out that we can't make f of x equal to 0. There's no way it's possible that we can make it equal to 0. Now, there's a fancy name for these two lines that just happen to be the x-axis in this case. This line right here, this line right there. But for right now, do we understand that when we graph this, we're going to get a branch up here, we're going to get a branch down here, and we can never make f of x equals 0, so the x-axis is offline, and we can never make, if we plugged in x equals 0, we get undefined. So when x equals 0, f of x is undefined, and that's going to take care of the y-axis. The x-axis, f of x never equals 0. That's what it comes down to. Those are the two ideas. And for f of x equals 1 over x, if you can show me that one of those is false, you'll make $1 billion and you'll be super famous and you'll be a rich mathematician. And here's the thing, it's not going to work. Sorry. It just doesn't work. Now, I know this is kind of crazy. If you go and you read and you watch the video and you see how it kind of plays itself out like that, you'll see how everything kind of works from it. But if I just kind of get rid of everything from this, and I have a clear picture, what I'll say is there's a line right here that says when x equals 0, f of x equals 1 over 0, which is undefined. And then there's a line right here that says f of x, which is equal to 1 over x, can never be equal to 0. Because there's no way that I could possibly make that happen. Because there's a 1 up there, and there's no way that I can make... I can't let x be equal to 1 over 0 because that's undefined. That's the only way it would happen, is if I used an undefined number. Now, these two lines, that line right here and this line right here, they have special names. And this is something you got to write down because this is an idea that you're never going to get away from. This is what's called the graph where the line doesn't exist, and there's a reason why it doesn't exist. And in this case, it's because we can never let f of x equal 0. We can never let, when x equals 0, there's no f of x. It's called an asymptote.
I remember when I was in high school and I first learned about the asymptote, and I was like, what the heck does this stuff mean? Because I think I was absent the day that they started talking about it. And asymptote, asymptote, all this is a line where the graph doesn't exist. That's it. And for whatever reason, if the graph doesn't exist at that line, we could draw a dotted line at that line, and we're good to go. Now, sometimes we have vertical asymptotes, we have horizontal asymptotes, and we have what we call oblique asymptotes, where we have a line that's diagonal. But those are for different types of functions that we have. We're not going to worry about those quite yet. Well, we might see some here and there. But your study of asymptotes are going to be kind of on the basic side in Algebra 2. When you get into pre-calculus or trig, your study of asymptotes is going to deal with more of the vertical, horizontal, and the oblique. Because the obliques are special, the horizontals are kind of special too. But let me just tell you this. As long as we're in the realm of rational functions, as long as we're here, we are always going to be dealing with asymptotes. And you are always going to want to find your asymptotes. Alright, first off, does that make sense? You got the general idea what the picture looks like? It looks like this weird, you get two different branches. One goes to positive infinity and positive infinity. The other one goes to negative infinity and negative infinity. That type of thing. We're good to go? Alright, so that's kind of part one. So